Hello everyone, we are going over the levels 1 through 3 for the A.REI.6 standard. And lesson, this is going to be split up into 3 lessons. Our first lesson is going to focus on solving a system of equations by graphing. So when I ask you to solve a system of equations, a system of equations is 2 or more equations, and we want to figure out the x and y value that would make both of these equations true. Now, if we are trying to find the solution to a system of equations by graphing, we graph. So in numbers 1, 2, 3, and 4, we are going to need to put each of these equations into slope-intercept form. A reminder, slope-intercept form is when we have y isolated. So number 1, let's do that now. I'm going to subtract 3x from both sides in my top equation. I wind up with a negative 2y is equal to a negative 3x plus 6. And then now I'm going to divide by negative 2 on both sides to have y is equal to a positive 3/2 x minus a 3. All right, we'll graph that in a little bit. Now in my bottom equation, I'm going to subtract x from both sides, and I wind up with y is equal to a negative x plus 2. And that's all I have to do for my bottom equation. So my top equation, I'm going to graph this one in red. I have a y-intercept of negative 3 and a slope of 3/2, which would mean I go up 3 and over 2, up 3 and over 2, or I could have went down 3 and over negative 2. But this is what my line, oops, let's try to redraw that. This is what my line would look like. Okay, my bottom equation I'm going to graph in purple. I have a y-intercept of 2 and a slope of negative 1, which means I go down 1 and over positive 1, down 1 and over positive 1, or I could have went up 1 and over negative 1. This is what my purple line looks like. Now, when I ask you for your solution to a system, what we are really trying to identify is where these 2 lines intersect on the graph. Well, we have an intersection point. Whoops. My intersection point is this point that I'm highlighting in yellow right now, which is the point 2, 0. And when we find the solution to a system of equation, we write it in ordered pair format. This is your solution. Now I'm going to show you how we know that this is the solution. Well, in my original equation, 3x minus 2y equals 6, if I put 2 in for x and 0 in for y, I would wind up with a true statement, because I get a 6 minus a 0 is equal to a 6, which is a true statement. And in my bottom equation, if I put 2 in for x and 0 in for y, I also wind up with a true statement because 2 plus 0 does equal 2. So this point satisfies both equations. That is how we know that it is the true solution to this system. All right, we're going to go over number 2. Again, we need to isolate y in both of these to graph. So I'm going to start off in my top equation by subtracting x from both sides. And then I'm going to divide by 3 on both sides. I wind up with a negative 1/3 x plus a 2. Okay, next equation, I'm going to start off by subtracting x from both sides. And now dividing, sorry, that should be a 6. Now dividing by negative 3 on both sides. I wind up with y is equal to a positive 1/3 x minus a 2. So in my red equation, I have a y-intercept of 2 and a slope of negative 1/3, which would mean I go down 1 and over 3, down 1 and over 3, down 1 and over 3, or I could have went up 1 and over negative 3. And this is what that red equation would look like on the graph. Now my purple equation, I have a y-intercept of negative 2 and a slope of positive 1/3, which would mean I go up 1 and over 3, up 1 and over 3. We are just looking at where these two lines intersect on our graph, which we do have their intersection point, which is right here, and that is the point 6, 0. Now, your two lines will not always intersect on the x-axis. It just happened that numbers 1 and 2, the two lines intersected on the x-axis. That will not always be the case. All right, moving on to number 3. These are already in slope-intercept form for us, so we can go ahead and graph right away. I'm going to graph my top equation in red, just how I have been doing it always. And my y-intercept is a 1, and my slope is a positive 2, which means I go up 2 and over 1, up 2 and over 1, or I could have went down 2 and over negative 1, same thing. But this is what my red line looks like. My bottom line I'm going to draw in purple, just like I have been doing. I have a y-intercept of negative 3 and a slope of 2, which means I go up 2 and over 1, up 2 and over 1. Or I could have went down 2 and over negative 1. But this is what my purple line looks like. Okay. These lines are parallel. They will never intersect because parallel lines do not intersect. So this means that we cannot find an x and a y value that would satisfy both of these equations. So this is no solution. Notice that the slopes of both of these equations were exactly the same. Same slopes will give you parallel lines. And when you have the same slope, but different y-intercepts, and that means that your lines will be parallel lines that don't intersect. Let's look at number 4. So for number 4, I need to get my top equation in slope-intercept form. So I'm going to start off by subtracting 2x from both sides. And I have a negative y is equal to a negative 2x plus a 1. And now I'm going to divide by negative 1 on both sides to get y is equal to a positive 2x minus a 1. Now I'm going to do the bottom equation, which I'm going to start off by subtracting 4x from both sides. I have a negative 2y is equal to a negative 4x plus a 2. And then now I'm going to divide by negative 2 on both sides. And I wind up with y is equal to a positive 2x minus the 1. So my red equation, I have a y-intercept of -1, and I have a slope of 2, which means I go up 2 and over 1, up 2 and over 1, and this is what your red line would look like. Now my purple equation, I have a y-intercept of -1 and a slope of 2, which means I go up 2 and over 1, up 2 and over 1. This is what your purple line will look like. Well, it looks like the red and purple line lie on top of one another, which means that there are an infinite amount of intersection points, because all of these yellow dots that I'm drawing right now are intersection points. And since both of these lines go on forever and ever, that means the intersection points are going to continue forever. So what that means is that no matter what I put in for x and y in one of my equations, the same x and y in value will always work out in my second equation. Therefore, there are an infinite amount of solutions. So we would say that there's infinitely many solutions. There are too many solutions for us to write down. Something you may have noticed in your equations. Well, in the top equation, I had a slope of 2. In the bottom equation, I also had a slope of 2. And your y-intercepts are exactly the same. If you ever have two equations with the same slope and the same y-intercepts, you will always wind up with your two equations having infinitely many solutions. But again, remember, if you have the same slopes and different y-intercepts, then you have no solution. To find one solution like we did in numbers 1 and 2, all you need between your two equations are different slopes. The red equation in number 1 had a slope of 3/2. The purple equation in number 1 had a slope of -1. Those are different slopes, which made us get one solution because the lines intersected. Same with number 2. The slope of my red equation is a -1/3. The slope of the purple equation is a positive 1/3. Those are different slopes. We wound up with one solution. So this is solving systems by the method of graphing, and we are going to learn 2 more methods of how to solve a system of equations. Please continue to video 2.